Okay, let's look at number 7. Okay, so the question is, what are the values of a and b, right? What are these values that would make this function continuous everywhere? So this is a line that's continuous everywhere. This is a line that's continuous everywhere. This is a quadratic that's continuous everywhere. So what I really want to know is I want these two to touch at x equals negative 3, and I want these two to touch at x equals 0. So let's go and actually do that, okay? So let's start with at negative 3. So I'm going to find out the limit as x approaches negative 3. Let's figure I want that limit to be, the same from left to right. So let's see what it is as we approach it from the left. So I think you guys would agree I'd use x plus 8. In this case, it would be equal to negative 3 plus 8 or 5. So what I want to happen, right, is I want to take the limit as x approaches negative 3 from the right of this function, and I want it to be equal to 5. So in other words, when I plug in negative 3 for x, I'm going to get a times negative 3 squared plus b. This is going to be equal to 5. So what is that? That's 9a plus b equals 5. I'm going to take that. So I'm just going to kind of tuck it over here for right now. And the reason is notice I have two variables. I have a and b. In order to solve an equation involving two variables, you need two equations. So this is equation number 1. Equation number 1 is 9a plus b equals 5. Why? Because that would make these two limits equal to each other. I'm now going to do the same thing at 0. I don't know why I wrote a 10 there, right? I'm going to do the same thing at 0. I want these two things to connect. So I'm going to take the limit as x approaches 0. I'm going to do it, it doesn't matter, so I'm going to do it from the right because I can use the kind of the known equation for now. And I think you'd agree I get negative 4. So really, I want the limit as x approaches 0 from the left of this equation right here to also be equal to negative 4. So we plug in 0, I think you'd agree, I get a times 0 squared is 0, so I get b equals negative 4. Okay, well that's nice so far. I know what b is. Let's make it a capital B. So let's keep on going. So I know that b is 4, or negative 4, so now I can say 9a plus b, which is negative 4, equals 5. So 9a equals 9, a equals 5. Okay? Now I didn't ask you really to, all I'm asking for are what are those values. So this is all you really need to show. I would say, honestly, well, no, this is all you really need to show. You could get away with a little less, but this is good. You don't have to go any further in justifying it. Okay? Let's keep on going. Let's go to number 8. Okay, so this one I'm trying my best to kind of force you to use some properties. So we're going to find the limit as x approaches 2 of 7 times the square root of the function. So we know, right? We know we were given earlier, and I'm just going to kind of put these givens down so I don't forget them. We know that the limit as x approaches, that's a terrible arrow, as x approaches 2 of f of x equals, what does it equal? It equals 9. And for g of x, is it g of x? Yeah, the limit as x approaches 2 of g of x equals 3. So I can apply some properties here. So one of the things I can do, right, if I wanted to, is I could say this is 7 times the limit as x approaches 2 of the square root of f of x. This is a composite function. So I can go find out what is the limit as x approaches 2 of f of x. Then, right, then I can say, I can then say, oh, well, that limit is 9. So then we just go and evaluate this, and there we are. So again, I can, whoops, I don't mean to scratch on this. I could take the limit of the inner, find out what it is as a composite, and then just evaluate the outer at that number, okay? So that's 8. Let's move on to B. Let's move on to 8B. So for B, what do we got here? We got the limit as x approaches 2 of g of x over f of x plus x minus 8. So this is another one of those cases where it's kind of nice to split things up. You may disagree, but I think it's going to make this a lot easier, and I think it's going to make it a lot clearer for those of you who might have had some difficulty with this, right? So I'm going to break it up into this, because when I do this, it becomes a lot clearer as to what is going on here. Let's see what's going on here. Well, for the first one, I think you'd agree. I take the limit of the numerator divided by the limit of the denominator. So g of x, what was g of x? G of x was, where do I have it? It was 3. F of x, I believe, was 9. Okay, that's good so far. What about the next one? Oh, that's a flashcard, right? I just evaluate x at 2, so that's 2. And the other one's also a flashcard. I get 8. That's it. So by breaking it up, I kind of got a nice visual where I might have had some difficulty with these pieces, the way they were written. It may have been confusing, but breaking it up, it really illustrates what was going on there. Okay, let's look at the last one. I have this. I'm going to grab this graph really quickly. What do we got here? Okay, let's go and figure out the different things. So the first one is asking for A, the question is, what is the limit as x approaches -3 from the left? So 1, 2, 3. So we're approaching it from the left. I think you guys would agree as I approach -3 from the left, the output is +2. Okay, what is B asking? B is asking same number, but I'm approaching it from the right. I think you'd agree. It's also approaching 2. Then C asks, what is the limit as x approaches -3? Well, left-hand side equals right-hand side, right? They're both equal 2. Therefore, the limit is 2. Now, the next question is this function continuous at x equals, what was it? -3. I think you guys would agree. F of x is not continuous at x equals -3 because f of -3 is undefined, right? Just by going through definition, I can see, oh, that's undefined. Okay, cool. Okay, let's keep on going. E, it asks, what does E ask? E asks, what is the limit as x approaches -1? So in this case, I think you'd agree the limit doesn't exist, right? Because as I approach it from the left, it equals -2. As I approach it from the right, it equals -3. So I'm going to say does not exist, but I did ask you to explain why, and I'm going to say the limit as x approaches -1 from the left of f of x equals 2, which is not equal to the limit as x approaches -1 from the right of f of x, which equals, excuse me, that will be -2. This is going to be equal to -3, right? So -2 does not equal -3, therefore the limit does not exist. And then F asks, what is the limit as x approaches 1 from the right? I think you guys agree as I'm approaching, whoops, I'm not meaning to write on there. As I'm approaching 1 from the right, this is just going to pos infinity. So I'm going to say does not exist. It's going to pos infinity. Remember, this is a description of how it fails to exist. Was there any more questions? I think that's it. Let me double check. Nope, that is it. Okay, 3 videos. I will see you in class.